So for the first one, what are the chances that the spinner will land on yellow? So how many yellows are there? 2 out of how many total? 8. And then reduce that, so what's it going to be? Yep, 1/4. Okay, what are the chances that the spinner will land on an even number? So how many even numbers are there? There's 4 even numbers, 2, 4, 6, 8. Out of how many total? 8, and then that reduces to what? About 1/2. Okay, what are the chances that the spinner will land on an odd-numbered blue? So how many odd-numbered blues are there? Only 1, just 5, right? So 1 out of 8. Okay, any questions on that? Okay, so your objective is students will be able to calculate the probability of independent events and conditional probability. Okay, so probability is just how likely something is to happen. So we're gonna have 2 types of probability, but like 3 types of questions. So you're gonna have independent events, and you're gonna have 2 types of questions that go along with independent events. You're gonna have ones where it's just a single event happening, so the probability of one thing happening. And then you're also going to have the probability of like 2 independent events happening, but they're not affected by what happens the first time. So like tossing a coin. So you flip a coin, and then you like flip a coin again. Does the second time you flip a coin, is that affected by what happened the first time you flipped the coin? It doesn't matter if you got heads or tails the first time. Is that going to affect the second time? No, right? Because you're just reflipping the coin. It's not going to have any impact on it. So that's going to be independent. Conditional probability. That is going to be when something is affected by previous events. So independent events are going to be for the 2 types of questions that are like more than one thing. There's going to be your with replacement. And conditional is going to be without replacement. Meaning, if I have, like, let's say a bag of marbles, different colors, and I'm going to pick 2 marbles out of that bag. After I pick the first marble, if I put the marble back in the bag and then go to pick the second marble, is the probability the same both times? If I restart and put the marble back in the bag and all the marbles are there again the second time I do it? Yeah, so the probability stays the same, right? That's going to be your with replacement. So you're putting it back, and then you're restarting from the same spot that you were before. Without replacement is, let's say I took a marble out of the bag, and then I put the marble in my pocket, and then I went to take a second marble out. Now do we see how like the probability would be different because it depends on what I got the first time? Yeah? Okay. So that's without replacement. So that's the conditional probability. So anytime you're doing, whether it's this one or this one, if you are doing the probability of independent events, you always multiply them together. So you take the 2 probabilities and multiply them. And this is going to always be like the notation that you use, P, A, and B. So that's going to be like, A is going to be the first event happening, B is going to be the second event that happens. Okay? So we're going to first start out with independent events, just one event, and then we're going to do ones like this where it's 2, one after the next, and then we'll move to conditional. Okay? So, first one, what is the probability of getting ahead when tossing a coin? So, that's one event, you're tossing the coin one time. So, probability of getting ahead equals. How many heads are there on a coin? 1 out of how many total sides? Yep. Okay, you gotta try that next one. Okay, so what's the probability of getting a 4 or a 6 when rolling a die? So the probability of getting 4 or 6. So how many sides is that like we would want?
Oh, 2.
2, yep. And then how many sides are on a dice? A dice? Like a game? Okay.
One, you can get like 1 through 10, right?
Wait, how is there 6?
Guys, like a dice that you roll.
There's 6
Oh,
sides
I
on a
thought
die.
you meant like die, like
No. 2 out of 6, and then what does that reduce to?
1/3.
1/3. Mm-hmm.
Where'd you get the 2 from?
I don't know.
Where'd you get the 2 from?
Because you could get a 4 or a 6. So that's 2 numbers that you would win.
Green.
So 2 numbers out of 6 numbers are like the winners numbers. Huh? So it's like the probability that that the dice is gonna land on a 4 or a 6. Yeah. So that's 2 numbers out of 6 numbers.
Oh, I see.
Okay. All right. So those are just like independent, just one event happening probabilities. Now we're gonna do 2 of those events happening one after the next, but they're still independent of each other. Like they still don't affect each other at all. Okay. So second example, a bag contains 3 red marbles and 2 blue marbles. What is the probability of randomly choosing a red marble and then a blue marble if you replace the marble after choosing? So I'm gonna draw a picture just to visualize. Okay, so we have 3 red marbles. And 2 blue marbles. Okay. So the probability of randomly choosing a red marble. So first we want to see the probability of choosing a red marble. So the probability that we choose a red marble is there. How many reds are there? 3 out of how many total? 5. Yep. So then I'm putting the marbles back, so I'm restarting with all these same marbles. Okay? So then we want the probability that we'll choose a blue marble. How many blue marbles are there? 2 out of 5. So those are the independent probabilities of those 2 things happening. To find the probability of red and then blue happening, like in order, which is less likely, you do probability of red and blue equals, you multiply those together, 3/5 times 2/5. So what's that going to make? 6 over 25. Can you reduce that or no? No. Does that make sense? Okay. So the reason why it's less likely is because, like, the probability of getting them in that order is going to be less likely. So a red one first and then a blue one instead of, like, any other order. Okay? All right, try the next one.
3.
No, you said 3 times it. Wait.
Okay, who's ready to go over it?
Yes.
Okay, what is the probability of flipping a coin 3 times and getting a head all 3 times? So first let's find the probability of just getting heads. So what's the probability of getting heads? How many sides are there on a coin?
Won't be 3 over 2.
Guys,
It's
Really?
1
just the
half.
probability of flipping a coin 1 time and getting heads.
1
1 half, yes, 1 out of 2. Because 1 side is heads out of 2 sides, right? Yes? Okay. So that's the only probability we need because that's the same outcome for all of them. So now we want the probability of getting heads, and then heads again, and heads again. So you're gonna do 1 half times 1 half times 1 half, and that's gonna equal what?
1/8.
Thank you.
Oh, sorry.
1 half. Does that make sense? Because like you just multiply all 3.
These are worded so like weirdly. Like,
I know.
that's what I don't
I know.
understand.
Yeah. Okay, so those ones are like of 2 events happening in sequence, but each of the events like have their own probability, like they're not affected by each other. Now, conditional probability is when the probability is affected by the other probability. So you're still going to multiply them together. It's still going to have the same A and B, but right here, this little notation right here, so this is the probability of A. If we look at the last page, so see how this one was the probability of A times the probability of B, like they're separate. This one says the probability of A times the probability of B given A, is how you say that. So this is the probability of B given A. What that means is the probability of B happening given that A has already happened. So you have to take whatever the result of A was into account. Okay? And these ones are going to be all the ones that are like your not replacement. So let's go actually back up to this example 2 and highlight if you replace the marble. So that's going to be like your with replacement. Okay? That's how you know it's that kind. Okay. So now conditional probability, the wording is going to be like you don't replace it. Okay? So, example 3. What is the probability of drawing 2 kings in a row from a deck of cards if you do not replace the cards that are drawn? So the keywords here, if you do not replace. So that's without replacement. Okay, so we want the probability that we're going to get a king twice in a row. So we have, let's find the probability that we get a king in the first place. Okay, how many kings are there in a deck of cards? 4 out of how many total cards? You know how many cards are in a deck?
32?
52, yeah. Yeah, 52. And then we can reduce that. By 4. Does anyone want to do it?
Oh, wait.
Keep going.
13.
Yeah, 1 over 13. Mm-hmm. Okay. Now we're going to find the probability that we'll get a king given that we already got a king. Because what's happening is I'm drawing the king out of the deck of cards the first time, I'm putting that king in my pocket, and then I'm going for another card. Okay, so it's not going back in the deck so that the probability stays the same. So now, what's the probability that I'm going to get a king given that I already got a king? So how many kings are left to get? 3. How many total cards are left? 51.
How is there 3 left?
3 kings left because there was 4, and then we took 1 out. Yeah, so this is like the probability that the second time we'll get a king, given that we already got a king the first time. So there's a king out of the deck, huh? Yeah. So it's 1/13. You said? Oh no, it's 1/13. So what's this reduced to? 1/17. Okay. Yes. Because there was 52 cards, and then I drew the first card, and it was a king, and I put it in my pocket. So now there's only 51 cards left in the deck. Does that make sense? Is everyone clear on how we did that so far? Okay, so now to find the probability of those two things happening sequentially, so probability of king and king equals, you're going to multiply those together, 1/13 times 1/17 equals 1/, I think, 221? Yeah, 221. Okay, we good on that? Good? Or no?
Get it?
Try the next one. I'll draw a picture. That's right.
I got 3 times 2. Hey.
Okay. So there are 2 blue marbles and 3 red marbles. What is the probability of drawing a blue marble and then a red marble if you do not replace the marble? So the probability of drawing which one first? Blue equals what? Yeah, 2/5. And then what color next? So red given blue. Okay, so we took a blue one out, right? So how many red ones are there? 3 out of how many? 4. Yeah. Because we already took a blue one out. Yeah, so this is, yeah, the without replacement ones is like that, it's removed, and then the next time you go, it's like you have to, it's gone. Yeah. Okay, and then the probability of blue and red. So you do 2/5, guys, times 3/4, which is 6/20, which reduces to 3/10. So you always multiply the probabilities together. Because this is the probability of only the first thing happening, just drawing the blue. This is the probability of only drawing the red, but this is the probability of those two happening in order. It's red given blue. So there's probability of red given that you already took a blue one out. So this is like the notation for all the without replacement ones. So like the independent probabilities are going to look like this. just probability of this happening, probability of that happening, because they're separate. They don't affect each other. But the conditional probability ones are you have to account for the first thing happening. Okay? Okay, lesson check we have to do. Everyone needs to do the lesson check, guys. So focus. Guys, are you actually kidding me? Like, okay. For the marbles, these 3 and that one are green. So you have 4 green, and then the rest are red. Okay? So you are finding, for number 1, just the independent probability of red. Number 2, you're finding just the independent probability of green. Number 3, you're finding the probability of red, given that you already got a green one out. Number 4, you're finding the probability of green, given that you already took a red one out. And then 5 and 6, you're finding the probability of red and green, but the replacement is what changes. So probability of red and green. And this is going to be with replacement. And then same thing, probability of red and green. But this one's going to be without replacement. Are you multiplying? The last 2, 5 and 6, you should be multiplying 2 things together.
No, which one was red?
Oh, these 3 are green, and then this one's green. Yeah, the light ones are green, and the dark ones are red. That's like if you put the marble back after the first time or if you don't. With replacement is you do put it back, and then without replacement is you don't. But this is a lot like what the test questions for this look like. So I'd pay close attention. Mm-hmm. Okay. Mm-hmm. Okay, are we ready? Okay. So what is the probability of just getting a red one out? How many red ones are there? 6 out of how many total? So that reduces to what? Yep, 3/5. Okay, and then green? 4 out of 10, so what? 2/5, yeah. Okay, so those are like your two independent ones, okay? The probability of red given that you've already taken out a green. So if I already removed a green, how many red ones are there? There's 6 red ones out of how many total? Nope, because I took a green one out. 9, yeah. So 6 out of 9, so that reduces to what? Yep, 2/3.
Wait,
Mhm.
how come on like all the other ones you subtract from the denominator and
Well, this one we did, so that's if like, so we're finding the probability of red given green. So we already took so like on this one, we were doing the same thing, king and king. So we subtract from the numerator because we were getting the same thing twice. This one, it's like red, but we already got a green one. They're like, we got 2 different colors. Does that make sense? Okay. All right, so probability of green given red. So if I already took a red one out, how many green ones are there? 4 out of how many? Okay. So probability of red and green, so red happening and then green happening with replacement. With replacement means that the two probabilities are independent. So you're going to use number 1 and number 2 to multiply together. So 3/5 times 2/5 equals 6/25. Okay, probability of red and green without replacement is when you're going to have to use one of these guys, okay? So the probability of red is going to be 3/5. And then the probability of green given red is number 4, so 4/9. So you get 12/45, which reduces to what? Four over 15? Yeah. No, because that's the probability of getting red given that you already got a green. So the probability of red is the 3/5, and then now we're on the probability of green given that we've already gotten a red. Does that make sense?
so what's the thing now 5 and 6? Like how do you know like the replacements? Like what's it do?
With replacement versus without replacement.
Yeah, like what is the difference?
So with replacement means that like you picked a red one out, you put it back, and then you're starting from scratch with all the same marbles again. So they're two totally independent things. That's why you use number 1 and number 2 for those. Without replacement is you picked a red, you put it in your pocket, and then now you're going to pick a green. So the probability of the second time of getting a green is dependent on the fact that you got a red already. So that's going to be when you use this one, number 4. The probability of getting green if you already got a red. Does that kind of make sense? Because like in these two, number 3 and number 4, those are finding probabilities of red and green if you've already taken a marble out and thrown it away. Whereas 1 and 2 are just finding the probabilities of getting one color or the other if all the marbles are there every time. Kind of?
Yeah, so without replacement you do like whatever like the second one is. Like so if it's green, you do like what you did green on the second.
Green, you find for the second one, you find the probability of this given this. Yeah.
But the first one's always the same.
Yeah, the first one's just independent because it's like the first time you're doing it. So like there's nothing's affected it yet. What's that reduced to 12/45? 4/15? Yeah. Yeah, it's kind of mush.